Hey guys, Doug Darbro. Multi-level, gosh, multi-level linear modeling, Math 6620. I threw this PowerPoint together. Let me give you an idea of the game plan here. I want to go through this very quickly just to set the stage, give you an indication of what I'm going to teach you, what you're going to learn, and then we're going to go through a couple of examples that have, little differences. At the end of this, you're not going to be an expert in multi-level linear modeling. That's actually kind of hard to say when you say it quickly, um, but you're not going to be. Okay, I'm still learning this stuff. As someone who came through their PhD program in the late '90s, this stuff was just these techniques. This technique was uh, just hitting the market, so to speak. So. Um, I'm kind of self-taught on this, but the good thing is once you get through once I guess you can say once the smoke clears, easy for you to say, right? I tell you, it's early in the morning. I haven't had my second cup of coffee yet, so this may be a little bit dangerous putting up a video that I'm probably going to have posted for some years, but we will get it done. All right, so let's get into this. Let's stop talking and let's make it happen, guys. What is it and why does it matter? Um, I absolutely despise when a professor or a presenter uses PowerPoint, and reads to you. So I'm going to do my best not to do that. But education research can be messy. What I mean by that is, just think about it. We have all these constraints in getting education data. You have pep rallies and you have students who miss and you name it. I know my wife's a school psychologist, and the story she tells me about trying to observe and collect data on children uh, is messy. All right. But even more than that, education research can be nested into different grouping factors, different populations, types of students, and so on and so forth. Now, the question comes to when you collect data, let's say we collect data across three school districts. Well, we know how school districts vary, and even more importantly, the students within the school districts may be correlated. Because let's just tell it like it is, some school districts are more effective than others. So if we are seeking only to generalize within a particular school district, then this mixed linear models may not be something that we need to implement. But if we're taking data from three different school districts where we expect the measurements within each school district to be correlated, then we have statistical issues, which I'll talk about in just a second. So sample sizes may be small. Most importantly, when we have nested data in classrooms, we get very possibly measurements that are correlated, so our independence assumption is violated. If you remember back in 6610, if you took that with me, which most likely you did, when we talked about ANOVA, we had three assumptions: independence, equal variances, and we need normality. And I try to stress to you that if normality and equal variances, either one of those is violated or both, it's not a huge issue. We need to report it, make sure the reader knows, but uh, not true with independence being violated. And there's some mathematical advantages as well. Situations where HLM is needed. Well, anytime there's a clustering, in other words, the examples I threw together here, a therapist, we have different therapists, we have different classrooms. And of course, the ideal way to violate independence is to measure the same person at different time segments. Clearly, you have independence there. But let's say, for example, that we test students with something as a freshman. Uh, I know my daughters are sophomore and they take the PSAT, which is supposedly an indicator of how they'll do on the ACT and SAT, or maybe just the SAT. I have no idea. I haven't looked into it that much. I got other things kind of keeping me busy right now. Uh, but if we look at, say, an increase in measure on that particular test over from freshman, sophomore, junior, senior, so we would have 4 measurements, right? Well, there could be a lot of things that impact the increase or decrease or the change, the variability in those measurements. First of all, it could be the kid, be the student, right? Students go through things. Well, good days and bad days. It could also be the environment in which they're nested. So HLMs kind of seek to address those issues. Independence, we talk about that a lot. Remember, we must assume independence. In other words, our scores are not correlated. Now, guys, if we're dealing with a regression model where we're predicting some X's, we're predicting Y's from a set of predictors. Let's just call them X1, X2, up to XK. It's not the correlation between each X and Y that we're concerned with. It's the correlation between the predictors. So in other words, we don't want X1 and X2 to be highly correlated. That gets into something called multicollinearity, and that we've talked about previously too. But again, mixed models are an excellent tool to address this. And again, it's not an easy assumption to defend, especially in education, because we might want to measure the same kid multiple times, as I talked about before, taught by the same teacher, taught in the same region. Family members may be included, so on and on and on. Okay, but it happens, doesn't it? So things that I did back, I really feel old when I say this, right? But I did my PhD in the late 90s, which seems like forever ago. But the way I dealt with it back then is we looked at repeated measures ANOVA, which we've I think we talked about those in 6610. And of course, there were certain assumptions for sphericity, and I'm completely losing my train of thought here. There's actually something on TV that's got me distracted, so let me get back to this. We use a multivariate approach, which measures each separate dependent variable. Well, that's MANOVA, so we talked about that at the beginning of 6620. All right, I'm back. Okay, so currently what we do, well, there's these hierarchical linear models. They go by different names, mixed models, HLMs, multi-level models. When you see that, it's all kind of saying the same stuff. Now, it turns out that certain types of these are certain types of the other, but not vice versa. And again, I have a slide for that later. These models have made repeated measures ANOVAs essentially obsolete. Yeah, actually they kind of have. So anyway. So here's what's up with HLMs. You have, I have no idea why I said 6 of one over there. Oh, 6 of one, half a dozen of the other, right? I just stopped typing. So they come by different names, but they're basically the same stuff. And this is a very redundant slide. Sorry. All right, let's say we had an anxiety study, and classroom A is just has a teacher who is just an absolute wreck. And you can imagine if that teacher is leading that classroom, that their students, unless there's some extremely strong external source, as much time as kids spend with their teachers, the very nervous teacher could impact the way that his or her students approach learning. Classroom B contrasted, very calm, carefree, and very encouraging. All right, so if we were going to do an anxiety study about how anxiety develops in children, we have what's called a contextual variable. So the classroom would be that. So classroom A will be related. Well, the students in classroom A would be related. Students in classroom B will be related. So the results that, again, we're not really trying to generalize only to classroom A or classroom